we have been solving equations, finding, taking the equations themselves, graphing them, and realizing, so let's say I have an equation of y, that doesn't work, equation of like y equals 2x plus 3. And what we would be doing then is we would take the 0b value, which is 0, 3, and then our slope, and then we would graph it. And so we would have a line here. We do 0, 3. We do a slope of 2, so up 2 over 1, down 2 over 1, and then we draw a line. Okay? And what we were doing, whether you realized it or not, was when you drew the line and connected the dots, all the ordered pairs on this line, this line is made up of ordered pairs, an x input to a y output, right? So whatever my x is, I put in and I get my y value. And that creates this graph of a line. And everything on this line is what we call a solution to this equation. Okay, so that means any x value that I have and I go up to the line, that y value is a solution for this graph, or this function. Okay? So what we've been solving is, for all the values down here in the x, what are the values that on the y that make it true? Okay? And the reason why this is important is because, a lot of times you're looking at, we were talking about salaries, if I, what's the salaries, what would it be in how many years? A lot of times you see this in volume, how much can something take? What would the temperature be at this, type of situation, etc. So this is all a situation in which these mean something, okay? So today we're doing pretty much the same thing, except for now we're going to find where we have two equations and see if there's an actual solution for both of them. And why that is really important is when you have two conditions, finding where they equal is like what makes it correct or incorrect. So like an example might be a lot of time I go to building things, but weight is a huge thing. So if I have a bridge and I'm going to build it and I use certain materials, what's the maximum weight that I could have on this bridge based on those materials? So a lot of times they'll go with the weight versus like a cost of a certain material, and they have like when would be the intersection point, so what would be our maximum cost for that material. So you have these two conditions, and where they meet is where that solution makes sense then, okay? So today we're going to be doing graphing and finding solutions. So first of all, we want to understand what is a solution, okay? So we have these two functions here that we have an f of x function and we have a g of x function, okay? And we have these questions they're asking us, and it's saying, is 5, 1 a solution to f of x? Okay? So what that is asking me is, if I input 5, would my output answer be 1? Okay? So when it's saying is if an ordered pair is a solution to a function, it's saying if I input my x value, because remember x is input, right? Will my output be 1? So what I need to do is take the input of 5 and see what my answer is. And if my answer is 1, then that is a solution. Okay? So what this is asking is doing an f of 5 as my input, because that's my x as input. Okay? And now it wants to see if my output is 1. So I'll plug it in. I'll use this f of x. That's my equation I'm using here. So that will be negative, plug in 5, plus 6. So I'll get negative 5 plus 6, and that equals 1. So therefore, my input is x, is 5, and my output is 1. That's my output. Output or y, or you want to say f of 5, either way. And therefore, that is true, right? When I input 5, I get 1 as an output. So therefore, the answer to, is this a solution for this? The answer is yes. Does that make sense? Okay. So now, it's asking us, all right, is 5, 1 a solution for g of x? Okay. So now it wants to know if this ordered pair here, 5, 1, is going to be a solution, meaning if my input is 5 and my x value is 5, will my y value equal 1? That's what it's asking. So we're using the g of x now, so this one we're doing g of x over here. So we'll do g of 5, okay, equals, now we'll plug it in here, we have 3/4, put in 5 for x, minus 1, okay, and so does g of 5, input of 5, does that equal an output of 1? Let's see, I get 15 over 4 minus 1, which is like 15 over 4 minus 4 over 4, which is 11 over 4. Is 11 over 4 1? No. So therefore, this is no. And what this is saying is, if I would graph, let's graph f of x here. If I would graph f of x and it equals negative x plus 6, okay, and I have my graph right here, I'm going to do 0, 6, 1, 2, 3, 4, 5, 6, okay, because that's my b value. My slope is negative 1, right? If I graph this, down 1 over 1, down 1 over 1, and I go down like this, it's saying, well, if I plug in 5 for x, do I encounter, is 1, 5, 1 on the line? So 5, 1 is on this line, okay? So therefore that is a yes, okay? Now if I graph the g of x, do g of x here. If I graph g of x, which is 3/4 x minus 1, so my point is 0, negative 1, and my slope is 3/4, right? Good so far on that? So if I graph this, so 0, 1, and then I go up 3 over 4, okay, and I do this, so this is my g of x. It wants to know if 5 1's on this line. Well, it's not, is it? So therefore, it is not a solution. So that's why 5, 1 is not a solution. It does not fall on that line. Okay? Does everyone understand what I'm saying about a solution then? How, if it fell on this line, if it was a dot and order pair on this line, it would be a solution. But as you can see, it is not. It does not touch this line. Therefore, it is not a solution. So what we did was we plugged it in, and because they don't equal, we know it does not fall on that line. Okay? Alright, so now let's try negative 8, 7. So what I'd like you to do is to decide, is to mathematically decide if f of negative 8, does that equal negative 7? That's the question. So f of negative 8, plug in negative 8 to your f of x equation and see if you get negative 7. So go ahead and give it a shot and see what you guys get. Okay? Okay, so when you did the putting in the negative 8 equals negative 7, it does not, because if you plot it out, you have negative, and then you have negative 8 here, and then you add 6, this becomes an 8 plus 6, which is 14. 14 does not equal negative 7, okay, because that ordered pair is negative 8 comma 14, so therefore the answer to this is no. It is not a solution, meaning it is not a point on this line, okay? Then we move to the next one, and we do the or the g of negative 8, and that's 3/4, negative 8, minus 1. This becomes negative 6 minus 1, which is negative 7. Therefore, this is the order pair of negative 8, negative 7. It is the same. Therefore, it is yes, meaning it is a point on that graph, on that line. Okay? So far we have 2 points. It's a point on this one, but not a point on that one. This is not a point on this one, that's a point on that one. So let's look at the 4, 2. And if you did the 4, 2, you have the f of 4, and that equals negative 4 plus 6. So that's negative 4 plus 6, that equals 2. Therefore, this is yes, it is a point on the graph. Okay? And then we do the next one, the g of 4, and that's going to be 3/4 4 minus 1. So that's 12 divided by 4, which is 3, minus 1, that equals 2. And this is yes. So notice how we have the same point for two different functions that it is a line on both of them. Okay? When that occurs, we actually have what's called the intersection point. Okay? And that is the solution then where these two lines actually meet. So if we actually plotted that out, I plotted it before, so I'll do it again real quick. 1, 2, 3, 4, 5, 6. And just kind of go down like this. Okay? And then I'm going to do the other one, which is 0, -1, and then you up 3 over 4. And then connect. And notice that they intersect right there, which is the 4, 2 point. Okay? So that is the solution that is the answer you're looking for. So when it says try to find the solution for the two equations, you're trying to find the point in which they intersect. Okay? So the point where they intersect is the solution of those two graphs. Okay? So the point of intersection is the solution for those two functions or graphs. Okay, and then on the bottom you notice here it has the actual directions. It says graph each equation. Okay, and this is where we're solving them graphically. You graph them, and the solution is the intersection of the lines. Okay, this is the point that will be the common in both graphs. Okay, and to check your answer, you would take that and plug it into both equations like we did, and make sure that they equal, and that would tell you that it's true. Okay, so questions on solving by graphing. Okay. All right, so as much as we love that, we always have to throw in some curves, don't we? Okay. We actually are going to have 2 or 3 different possibilities here. So if you notice on the very bottom of your page, we have 3 different types of solutions. We have it where we'll have one solution, which is just like we did, where it's only one point of intersection. Okay. We'll have it where you have the exact same line for both, so when you actually do the y equals mx plus b, they're the same. That is what we call infinite solutions. And then we have it where they're parallel, meaning their slopes are the same, and if they're parallel, there are no solutions. Okay? So let's get an example of both of them. So let's look at number 1. What I'd like you guys to do is to graph. So you're not going to solve, you're just going to graph. So you want to put it into the y equals mx plus b format. Okay? Or if you want to just do 0, 0 for x and y and solve, you could. I think the y equals mx plus b is the best format because you can easily identify if they have the same slope, and you can easily identify if they're going to be infinite solutions because your equations would be the same, right? So if you put it in a y equals mx plus b, you actually have a really quick check. So go ahead and turn number 1, turn the top equation into y equals mx plus b, and then graph the two, and let's see if you can find the point of intersection. In looking at getting this to be y equals mx plus b, I would do -3y. I'd bring the 2 over, so it equals -2x plus 18. I divide by the -3, so y equals -2 over -3, which could just be 2/3 x minus 6. Again, take the 3 to all terms. So now I know my b is -6, so my first point is going to be 0, -6, and my slope is 2/3. Okay, so I can go 0, -6, and then I'm going to go up 2 over 3. Okay, and then I'll connect the 2. Okay, then the next line, I already have it in the b format, the y equals mx plus b, so my first point 0, 8, right? And then I'm going to go down 4, my slope is -4, I'm going to go down 4 over 1. Okay, so down 4 over 1. Down 4 over 1. And then connect. And when I connect, you should see that they intersect right here. And that point then is +3, comma -4. Is that what you guys got? So what that is saying is the value when x is 3, your output's -4, that is a solution that falls on both of those lines. Okay? Alright? So then if we move on to number 2, if you notice number 2, if you do y equals mx plus b, so I'm going to get negative 3y equals negative 12x minus 9. I divide by negative 3, so y equals 4x plus 3. Okay? If I do the other one, I'm going to get y equals 4x plus 3. Do you notice the lines are the same? The lines are the same, so therefore they're going to obviously overlap each other, which means all solutions for both lines are the same, or they are a solution, so therefore it is all real numbers. If I graph that, I'm going to go 0, 3, and then I'm going to go up 4 over 1. Okay, and it looks something like this. Straighter line would be good, and that's it for both. So here the solution on number 1 is going to be 3 comma negative 4. Here the solution for 2 is going to be all real. Okay? Alright, so if you look at number 3, if you actually put y equals mx plus b, you're going to get, okay, 6y equals negative 4x plus 18. Divide by 6, so y equals negative 46x plus 3. That reduces to negative 2/3. Okay? And if I do the other line, you can look at it, it says y equals negative 2/3 x plus 2. What do you notice about their slopes? They're the same. So if you have two lines and the slopes are the same, they're parallel, because we know that from last time, right? When they're parallel, do the lines ever intersect? No. So therefore, there's no solution on this one. Okay? And if you graph it, it'd just be 0, 3, and then you go down to over 3. And this would be this one line. And then the next line is going to be 0, 2, and same thing, down to over 3. And they're just going to be side by side, and they never touch. So therefore, it's no solution. Okay? If you did 4, did everyone get to 4? Did anyone not get to 4? Let me do it real quick. Okay, so number 4 is, if you would do y equals mx plus b, I'm going to get y equals 2x plus 5. So I have 0, comma 5, and my slope is 2. Okay, on this one, I'm going to get y equals, I got to divide by 2, so, or 1/2, which is multiplying by 2. So I get negative x plus 2. So I have 0, comma 2, and I have slope equals negative 1. Okay, so I'll go, let's see, 0, 5, and then I'll go down, or up to over 1, like that. Okay, and then the other one is 0, 2, and it's a negative 1 slope, so it's down 1 over 1, up 1 over 1. It looks like they intersect right here, and that point of intersection then is going to be negative 1, comma 3. Questions on those?